of attention here. So I want to quickly demonstrate something on how to do this, and I'll do something that will be subtly wrong, so that we see the where the unit testing would actually come in handy. So let me implement the remove method. Now, I gave you the chip and say, look at the get method. And I look at the get method, and there's a loop and stuff. And now I have the brilliant insight, and I don't actually have to write this loop now, do I? I could just call get to see whether the value is in there. And if it's null, I don't have to do anything. But if it's not null, then I can just do items. And items has a remove method that'll remove an object that's in there. So I'll just make the object. It's a new item of name key value. Because that's the object that I want to remove. Right? So that's clever. That way I don't have to do any loops. I'll just use the existing remove method that's willing to remove something that's in there. And so here this is just to check if it's not in there. Now I have to return something. I have to return the old value. So I'll do that. So nice and simple. So now let's see if it works. So I have my unit tests over here. And so this was the first one that I had. I'll just write a new one. Every test starts with add test. That way the framework knows what to do. Public void. And I don't know, what should I call it? I'll call it removing works. Now maybe later I come up with a better name. So I have an address book. I put in something in there with what is put Fred phone, and Fred's phone is 411. And now I want to remove it. So dir remove Fred phone. And now I want to check whether the removal worked. Well, how do I know if it works? So the best way that I can do is I can call get and see if I get null back. So I call it get Fred phone. And now I want to assert that that is null. So that's my test case. Well, let's run the the tester. So the first one passed. One test passed. That was the original one. And now my test case, it failed. Right? So this one here charmingly shows, half of it was good, but half of it was failure. Abject, total, and utter failure. But actually, that's not bad, because what failed now? Something went wrong in these 3 or 4 lines of code, and the lines of code, of course, that they call. That's something that's manageable, that you can analyze. It is much, much better to have failure in the small than failure in some big fat program with 200 lines. So, yes, it failed, but the failure is fairly localized, and now I can kind of think about this. So, what happened here in this case is that I called remove, and then I called get, and it didn't seem to have removed it. And let's find out why that is so. So here's my address book. So I called this remove method on the array list, and my hunch is that remove method didn't actually work. It didn't actually do the removal. Well, why wouldn't it work? So I have an array list. I say remove that particular object. And so what does the array list do? It goes through the first one and says, is that the one I should remove? Is that the one I should remove? And so on. So it needs to compare the object that I'm giving it with the one that it already has. And if they're equal, then it removes. How does it know whether two items are equal? It calls the equals method. Let's see if my item class has an equals method. No. That would be a problem. So this way I said remove the item that looks just like it, but it's not doing it because it doesn't know when two of them are equal. It just checks them by reference. So I need to add an equals method to it. I love it. So I can already get one here. Oh, that wasn't a very good one, but hey, I guess now I just need a. So objects, now I have to do item other equals. Remember we did this a few weeks ago. Return name equals other dot name and value equals other dot value and key equals other dot key. All right, now let's run the tester again. And it passes. Okay, and since I already had the tester in place, it didn't take me any time to run it. And so that's the beauty of having unit tests, that you isolate the problem. You don't have to look at the entire program, but only at the part of the program to find out what went wrong. And then when you make an improvement, then you can run them again, which is now no extra effort because you already have them. And then, with sooner or later it'll pass, and you feel happy. So the way that unit tests work is that, so the idea is, as you write the program, and the program gets better and better, you want to write these unit tests. For example, in homework 5 on homework, which one was the one where you had to do the sorting an array of length 3? It would be really simple to make 3 or 4 unit tests that test the various combinations, and then you would be able to see that your program gets a little bit better with every bug that you squash. So at first you have a bar that's probably pretty red, and then it'll get greener over time. And people enjoy this because it gives them the feeling that they're making progress. So just from a psychological perspective, unit tests are really, really wonderful. NetBeans makes it very easy to do it. You just need to set up this file. You dump your tests in there. Now, there's another unit test here that I didn't actually need. Where was the... No, here. This one here. Should I remove it? Never! You never throw a test away. So the idea of having a test suite is that every time that something went wrong, you make a test that demonstrates that it went wrong in just this particular way, and then you fix the error. Now, of course, the test will pass, but you leave it in place. You leave the test, which now always makes you happy and green, you leave it in place because there is this nasty phenomenon in coding that I think everyone has run into one day or another, that you fix a bug and next day it comes back. Did it ever happen to you? That you fixed something and everything was fine, but next day it just came back. It was overnight when you sleep. No. What really happens, of course, is that oftentimes people think they fixed a bug and they did the best that they could, but maybe they didn't really understand the problem. Happens to me all the time. Happens to everyone. And then when the rest of the program changes a little bit, and then the very same bug that you thought that you were working on, that it still acts up again. If you have a unit test, then that thing gives you a red bar, and now you might think red, that's depressing. But yes, it's depressing, but it's nowhere near as depressing as having a big, long program that broke, because you will not get to know exactly which test failed. And that test is 3 lines long, and you can work through those 3 lines and figure out in finite time what went wrong. So this whole idea of building the tests before you even write the code, and thus keeping them around forever and ever has turned out to be just a really productive thing. And people do this all the time, and as their code gets more complicated. In CS1, your code was so easy that it probably wasn't worth the effort. But now that we're in the middle of the CS2 class, your code is getting complicated enough that it is beginning to be worth the effort. And so lots of very successful programmers have this habit that as they code, for every unit of code that they do, they keep a unit test file. They just casually add tests. Usually I add a test when I have a failure. When I find a bug, then I make a very short test, a few lines long, that exhibits just this bug, and I just leave it in place. It stays there for years if that code ages that long. So it's a wonderful tool, and makes people really productive, which is why this fellow Martin Fowler said, JUnit is very simple, actually. When you look at the code, you can check out the code. It's maybe 1,000 lines long or so, which isn't much by any standards. And Fowler said, never in the field of software development was so much owed by so many to so few lines of code. Because it really is an incredibly powerful and useful technique. So go and try it out yourself. I will, in the next few assignments, I will start making you do some unit tests so that you get the feel for it. And I can't overemphasize just how useful a technique it is. It goes a little bit against human nature, because who wants to plan for failure? But you've been around the block long enough that you know that failure is what computer science is all about, right? You fail so much more often in programming than you succeed. You have to go past all of those cliffs and shoals before you finally get to the harbor of success. That it is a good idea to manage failure. And so that's what JUnit lets you do. All right, we'll finish the lab on next Tuesday, and the homework assignment after next, I'll start making you practice some unit tests.